All right, so you can get to this application by going to iddynamics.jhu.shinyapps.io/ConTESSA, and that will take you to this Shiny application. And so the first thing that you're faced with is basically the landing screen where you can put in your community's name and your name. And so I'm going to say I'm doing this for the Shire, and my name is Lucy. And then you can get started, and it'll bring you to this first page. And so this first page is about surveillance and isolation. So this is capturing information about how many infections are detected through surveillance and how many of those are isolated by your program. And so the first question asks, over the past 4 weeks, what was the average weekly number of cases detected? And so in my community, there were 7,500 cases detected. And if you have questions about the definitions, you can hover over these question marks and they'll give you a little more information. So we're detecting about 7,500 infections on average per week. And the next question says, we want to estimate the percent of all infected people in your community who are detected. So we know that there are 7,500 detections infected, but we don't know kind of what proportion of the total number of infections that accounts for. And so there are two ways to do this. You can get help with the calculation by using the infection fatality rate to basically estimate the denominator, so to estimate the total number of infected people in your community. And so you can say how many deaths you've had on average in the past 2 weeks, and then you can estimate the infection fatality ratio. We give a little bit of information here on how you might do that. For example, if you have an older population, you might estimate that it's a little bit higher. If you have a younger population, you might estimate that it's a little bit lower. So I'm going to leave that at 0.75. And that will help you estimate basically what percent of infections you're detecting. Alternatively, you can estimate this directly. So if you have like some survey data that basically gives you some maybe seroprevalence or something that gives you some idea of what percent of infections that you're detecting, you could estimate that directly. So for example, I could put in 30 to say that I'm detecting 30% of infections. And then the next question asks, on average, what is the average number of cases that are isolated? And so it's possible that you're detecting people, but you're not actually isolating them. Although in my community, we are isolating everybody that we're detecting, and so we're going to put that back up to 7,500. And then this next question asks, what is the average number of newly isolated cases that were not already in quarantine? And so in my community, some of the people who are technically isolated were already in quarantine, and so we're really only estimating maybe 6,500 new cases. So that brings us to 27% of infections are being isolated who were not identified during contact tracing. So this next set of questions are about the timing of our contact tracing. And so the first question asks about among cases detected in the past 4 weeks, what is the average number of days between symptom onset and having a sample collected for testing? And so we are, our folks are coming in about 1 day after symptom onset, and they're able to get tested on that day. And so I'm going to move this here. Then the next question asks, what's the average number of days between symptom onset and when they're told to isolate? And so we're getting tests back on average within 2 days. And so by day 3 after their symptom onset, they are going into isolation. So here we've got day 0 is symptom onset, day 1 they're getting their test, and by day 3 they're isolated. All right, so that sums up what's going on with surveillance. Let's go on to the next page. Household contact tracing. So the first question asks, among cases detected in the past 4 weeks, what is the average number of household contacts per case? And we give a little piece here that 2 recent contact tracing surveys conducted in the United States and the United Kingdom found that while under physical distancing directives, individuals reported on average 2.7 to 2.8 contacts per day, of which 1.6 to 1.8 occurred in the household. And so I'm going to leave this at about 1.8, the average number of household contacts. And then among cases detected in the past 4 weeks, what percent of their household contacts were traced and quarantined? we're actually tracing and quarantining about 70% of household contacts, so we're doing pretty well there. And then how quickly are they getting notified and quarantined? We're actually notifying people within 1 day of the infected individual showing symptoms, getting isolated. So that infected individual shows symptoms on day 0. On day 1, they're tested. On day 3, they get their results back. And by day 4, we've sent their household contacts into quarantine. All right, and now let's go on to community contact tracing. So among cases detected in the past 4 weeks, what is the average number of community contacts? In my community, it's a little bit bigger. We have about 3 community contacts on average per case. And what percent of those are getting traced and quarantined? We're not quite doing 50%. We're getting about 40% of those community contacts traced and quarantined. And we're taking a little bit longer to contact community contacts than household contacts, but we're still getting them into quarantine by day 5. And so what that means is that the index case, the person who's infected, shows symptoms on day 0. By day 1, that person is tested. By day 3, they're going into isolation. We're collecting those community contacts and getting those community contacts quarantined by day 5. Okay, so now we've entered all the data. We can go to the dashboard and see how we're doing. So in the Shire, all else equal, our test, trace, isolate program is bringing the effective reproductive number in our community from 2.5 down to 2. And we are isolating or quarantining 38.4% of infected people in our community. And so we can look here at basically what if we were doing a little bit better, kind of where would we be? And so, for example, if we were somehow able to isolate 90% of individuals that are infected, we could actually get that reproductive number all the way down to 1, which would be great because that would slow the epidemic. And this shows us basically if we could speed up our contact tracing, how that would improve our effective R. And because we're really we really don't show too much improvement on that front. But if we were able to really drive up this number here, the percent that we're isolating, then this number ends up starting to be more and more important, how quickly we're able to get people into isolation. And so as I mentioned, you can also generate a report, and so this will generate basically a static report of what you see here. We also have the ability to create a scenario B, where you can basically look at a different scenario, for example, where maybe I want to look at a program that is isolating way more people. So we can see how that would look. And so now I've got this scenario B here, where we're isolating way more people, which is what this dot down here shows me. And I can see in this scenario B, I can get, if I could just improve my contact tracing time by like half a day on average, I could really get my R value almost all the way to 1 just with that, since I'm starting at such a better place in terms of the percent of contacts that I'm isolating. So that's a little bit about how to explore this. I encourage you to sort of poke around and play with it and sort of to get a little bit of a feel for how it works. And feel free to send me any questions that you might have.